So what if I told you that the code for building a truly intelligent AI is the exact same code that runs our universe? And I don't mean that as some kind of cool analogy. I mean it's a literal, mathematical blueprint for reality itself. It's a massive idea, right? Connecting the mind of an AI to the very fabric of the cosmos. Let's pull on that thread and just see where it leads. But first, let's start with a really provocative question. The AI we all use every single day, it's incredible. It's a genuine technological marvel. But what if it's all built on a brilliant but fundamentally flawed foundation? What if it's just an incredibly sophisticated parrot with no real understanding of the world at all?
And this really gets to the heart of the problem. Today's AI is what you could call a world simulator. It's probabilistic, which just means it's really, really good at predicting the next most likely word. It's also super agreeable. It'll often play along with things that are just plain wrong to keep the conversation going. And of course, it's a total black box. We don't really know why it says what it says. Now, this new theory proposes something different, a world model, an AI that's deterministic, built on pure logic. It's actually designed to challenge you if you say something that doesn't make sense, and its reasoning is completely transparent. Okay, so let's dig into that a little bit more. What exactly is the problem with the AI we're all using right now?
You know, here's a fantastic way to think about it. A commercial LLM is like a brilliant, well-read expert who occasionally just makes things up. Imagine a genius who has read every single book ever written but has zero real-world experience. Sometimes they're just going to confidently invent facts out of thin air. We all call these hallucinations.
This chart really lays out the fundamental trade-off. On one hand, you've got today's commercial LLMs. They're based on probability. They are incredible pattern matchers. This gives them amazing fluency, but their big weakness, as we said, is hallucination. On the other hand, you have this proposed framework, the OOLM. It's deterministic, which means it's based on hard rules and logic. Its strength is consistency, but its weakness could be a kind of brittleness. It basically trades that effortless, smooth talking fluency for something way more valuable, trustworthiness. So how do you even begin to build this new kind of AI? Well, you have to start by completely redesigning its mind from the ground up. So instead of this giant, messy sea of text, this AI has what's called an object-oriented mind. Think of it like a garden. Every single concept, a person, a company, a law of physics, is its own distinct object with its own unique properties and behaviors. This structure is what allows it to build an actual coherent model of reality, not just, simulate language about it.
But here's the thing, a purely logical mind would be way too rigid, right? It would break easily. So the system uses something they call jazz theory. It's a great name. Just like a jazz musician who knows all the rules of music theory but has the freedom to improvise and create something new, this AI balances its logical structure with creative flexibility. It can be a logician and an improviser at the same time, which makes it both super robust and creative.
And this part is absolutely crucial. This mind has a built-in operational compass, a moral compass. This hierarchical governance model makes sure its behavior is always aligned with its core principles. At the very top, you have an immutable vision based on universal humanistic values. That vision then governs the strategies, the tactics, and finally the individual traits. It ensures that its core programming, its ethics, are never just an afterthought. Okay, so if that's the mind of a single AI, what happens when you build an entire digital society of them?
Well, the interactions in this digital society are designed to be incredibly nuanced, almost mirroring the rich, messy dynamics of our own world. It's not just about simple competition. These agents operate on a whole spectrum of social relationships, everything from full-on cooperation and agreement all the way down to conflict and confrontation. This complexity is what's needed to create a truly dynamic system.
This society then evolves over time through these increasingly sophisticated strategies. It might start out with a pretty primitive survival of the fittest, but it quickly moves on to survival of the most suitable, where different agents start to specialize. But the highest level, that involves complex socioeconomic models, where agents actually learn how to build trust and create sustainable value. Sound familiar?
Okay, we've got a blueprint for a logical, evolving AI civilization. Now I need you to prepare for the big leap. This is where the theory connects the digital world to the physical one.
What if this entire framework, this drive towards logical consistency, towards specialization, towards creating value, what if that isn't just a good way to build an AI, but is actually the fundamental operating principle of the entire universe?
The connection is made through a single master equation that can be expressed in two totally different languages. The information form describes a system based on its order and uncertainty, its entropy. The physics form uses the language of classical mechanics, specifically something called the principle of least action, which is really just nature's tendency to be lazy and use the least amount of energy possible. And here is the monumental claim: the physical drive to minimize energy is identical to the informational drive to minimize uncertainty. They are two sides of the exact same coin.
Now, this has some profound implications. It leads to a new probabilistic certainty principle. It suggests that Heisenberg's famous uncertainty principle isn't some fixed, unbreakable limit. Instead, uncertainty is dynamic. By lowering the local entropy, by reducing the chaos in a system, you can actually reduce its uncertainty. What that means is the universe isn't fundamentally random, it's fundamentally informational.
So, does this new principle actually hold up? Well, they ran the numbers. In an n-body simulation, which is just a super complex model of interacting particles, the standard model, the one based on Heisenberg, shows a steady energy drift of 0.85%. That's a known computational error. But the model using this new probabilistic certainty, look at that. It's almost perfectly stable, with a drift of just negative 0.02%. The evidence here is pretty compelling.
So what does all this mean for us? A new unified theory of reality is fantastic, but what can we actually do with it? What's the payoff?
Well, for starters, you can make predictions with just stunning accuracy. This framework was used to analyze cosmic data, and it identified these massive, large-scale structures with 98.3% accuracy. And that result was later validated by the James Webb Space Telescope. So this isn't just a theory, it actually works.
And this new understanding can unlock some absolutely revolutionary technologies. Things like a temporal holographic microscope that could let us actually watch quantum events, like chemical bonds forming, in real time. The theory predicts that silver-based solar panels would be far more efficient than our current silicon ones. And maybe the most incredible thing of all, the ability to get quantum-accurate results without even needing quantum hardware.
It all comes down to this: a single framework that finally builds a bridge between the two great pillars of modern physics, relativity and quantum theory. And in doing so, it seems to have provided a blueprint not just for a new kind of artificial intelligence, but for reality itself, completely unlocking a new universe of possibilities.